Welcome and thank you for joining me. Here we're going to take a look at some homework practice questions from lesson U2, A2. Let's get started with question number 6. We're asked to find the parametric equations for each of the following lines. So the first line is given in symmetrical form, so this is a symmetric equation. And the second one, again, is the symmetric equation. Now, notice that both symmetrical equations, they look similar, but there is a difference here in the second one. You see that we have a comma, and then we have just z equal to 5. So what that means is that the parametric equation for z must have been 5, which would have been the z coordinate in the direction vector, plus some scalar t, and the z coordinate of the direction vector must have been 0. And that's why we do not see the fraction in here, because it would have been undefined. Next, we have to find the angle between the two lines. So to find the parametric equation of a line, we need to know or write the equation in the form x equals x0 plus ta, y equals y0 plus tb, and z equals z0 plus tc. Recall that the coordinates a, b, and c, or the values of a, b, and c, will represent the coordinates of the direction vector. Now, for the first line, that would be 1, -1, and 1. The x0, y0, and z0 will represent the coordinates of the starting vector, and they are found right here. So we must have had in here x minus a -6, and that's how the 6 was produced in here. So we're going to write for this -6. For y0, we must have subtracted a +10, so that makes y0 here 10. And for z, we have subtracted a 7 here, which means that z0 must have been 7. A, b, and c will be the exact same denominators that we see in the symmetric equation. So -1, and this is +1. So this will allow us to write the exact equation. So x equals -6 plus t, y equals 10 minus t, and z equals 7 plus t. So now let's take a look at the second equation. In the second equation, we have, again, the same process. And what I'm going to do here for the second equation, I'm just going to copy this down so it's easier to connect the things together. And I'm going to try to make this a little bit smaller so we have enough room. And here we go. So we'll say that for the second line, now we're going to look at this symmetric equation. We're going to identify the coordinates x0, y0, and z0. So it seems that x0 must have been -7, so minus a -7 has given a +7 here. So for the y coordinate, we have subtracted a +11, so that makes y0 11. And for z, as you can see in here, we have 5. And that's what we're going to write for z0, 5. So for the direction vector, then we're going to say that it will be given by the denominators, which are 1, -1, and then 0. So 1, -1, and then 0. So therefore, the parametric equations will be -7 plus t, 11 minus t, and last we're going to write z equals 5 plus 0t, so simply 5. So these are the parametric equations of each respective line. We're going to make the sizes similar to organize the work. All right. And let me highlight all the findings very quickly. So first, second, and third parametric equation. And this is for the second line. Or these are for the second line here. Now the next question is asking to determine the angle between the two lines. Remember that each line is described by or has a direction vector. And the angle made between two lines is the same as the angle made by the direction vector. So with the direction vector m1 for the first line equal to, remember, 1, -1, 1. And direction vector for m2 equal to, again, 1, -1, and then 0. Then we'll say that the angle made between these two direction vectors will be found by using their dot product. So we're going to say that m1 dot m2 equals magnitude of m1 multiplied by magnitude of m2 multiplied by the cosine of the angle made between them. So let's put the coordinates in. 1, -1, 1 dot 1, -1, 0 equals square root of 1 squared plus -1 squared plus 1 squared multiplied by 1 squared plus -1 squared plus 0 squared, and then multiplied by cos theta. So multiply here the x's together and the y's together and the z's together. And we get 1 plus 1 plus 0 equals the square root of, here we have 1 plus 1 plus 1, 3, multiplied by the square root of 1 plus 1, so that's square root of 2, cos theta. So then we have 2 here. Root 3 times root 2 is root 6, cos theta. And we're going to say that cos theta equals 2 over root 6, which will make theta equal to inverse cos 2 over root of 6. So use the calculator to find the measurement. So second cosine 2 divided by square root of 6. And then we get the angle of 35.26 degrees. So about 35 degrees approximately. And that's how you find the angle made between these two vectors. I hope this made sense and I hope you find this useful. Thank you and thanks for watching and bye for now.